Ladies and gentlemen, good afternoon to all of you and welcome to our today's webinar talk on innovations in security. As you already know from our announcement, today with us is Mr. Hesham Enan and he is key account manager from Teledyne FLIR. Today, Mr. Enan is going to talk to us about the benefits of using dual vision cameras. So, Mr. Enan, welcome and thank you for joining to us today.
Thank you, Sid, for your introduction. Thanks also for our partners, Zodax, for giving us the opportunity to talk with you on this opportunity, where we are talking today about the benefits of the dual vision for automatic incident detection and fire detection, specifically for tunnels application. Why we are talking about the tunnel applications? Because this is where actually we can see the benefit, or let's say we can save lives. And this is something from Teledyne FLIR, or from previously FLIR, is one of the main important pillars to have this as one of our objectives as a company to save lives. Everybody may remember the Mont Blanc fire, 1999, where we have a lot of fatalities. It was a tunnel between France and Italy. We also have seen St. Gotthard Road Tunnel, which is also was a disaster in Switzerland. And I'm sure also everyone here on the webinar can remember one or two cases where we actually lost the lives of people because of one important thing. It's mainly the smoke. This is where the fire is actually hitting, and that part is when there is a smoke, people cannot know where to go. They start to shock, and they cannot breathe quietly. And most of incidents or the accidents caused of that thing. So basically, what we are trying to do here is to get a very early fire detection, because if we have the early fire detection, we don't wait until the smoke fills the tunnel, and hence we can save the lives of the people that are inside the tunnel at that moment. This is not something that we are doing recently. This is something that has been in the market, and we have been pioneering in it since 1930s. At that time, it was analog cameras, and we have been doing that using dedicated boards. We call it the VIP boards, and that's where the algorithm was on that boards, and we have been dealing with any third-party cameras. It's the same thing that are still there at the moment, but we started from the 2010 to put this analytics on the cameras itself, to be embedded on the cameras, especially the visual cameras. This is where we started with the IP cameras, and the high definition were coming also to the market. And this is where we decided to move, let's say, the analytics embedded on the camera. I know that other suppliers and other people can debate whether it is better to have it in the control center on a centralized server or embedded on the edge. But this is not, let's say, the discussion we're having here. If somebody is interested to know more about that, please contact me directly and we can have this discussion. Of course, we are seeing that an embedded on the solution is much more efficient and much more scalable, and latencies so less. They have too many advantages on that we can discuss it a little bit in another call. However, the main breakthrough happened when we introduced the analytics on the thermal cameras. The analytics on the thermal cameras are becoming very, very useful. This is where we are actually seeing the benefit of detecting the fire in that early stage, and we'll go through that during the presentation. But this is where the technology of the thermal became a little bit less expensive. It's not only used right now in the military application or in the defense application. It is currently used in several commercial applications, and one of the benefits is to do the fire detection using thermal cameras. The next generation is to have the Gen AI, the AI modules on the cameras itself to do the AI incident detection. And that's something that we'll discuss during the call. And this is where we are going actually to have something to explain it a little bit in more detail. Why the thermal? The thermal is because, first of all, this is what you can see. This is our visual and thermal camera. You are actually seeing what's happening on the thermal part. On the left part is the visual one. You can detect the smoke, but you don't see what's going on. And that's the main advantage of why the thermal is useful. Thermal is useful because you can see the event. You can actually detect what's going on. As you can see here, the pedestrian is detected. You're going to see cars moving, and the cars will be still detected. It can be counted. You can do everything. Let's say from the analytics, you can still see. However, with the smoke, you cannot see everything. You can only see very small parts. So that's something that we would like you to understand, or let's say see if this is really useful or not. The visual is very important, but again, during an event or during the thermal is during the fire, I mean, the thermal is the one that will be useful. So why the thermal can see through the smoke? And that's something that's a little bit more on the physics side. You can see here the smoke particles are normally between 0.01 micron to 1 micron, where they are covering the visible light. So basically, the smoke is bigger than the visible light, so we cannot see it. However, on the infrared, which is going from 7 to 14 micron, you can go through the smoke and you can still see it. So that's why the benefit of having the fire detection and the thermal camera through the smoke, because you can still see it. With the visual, we will not be able to see the fire itself. This is one of the most important slides today, and that's where exactly you will be able to see a real incident happening. On the right side, you see the thermal image. Maybe a lot of you, we cannot see anything. That's why we still need the visual, because that's where the operator are using. But here you can see the fire started on the right side. From the visual point of view, it is there, but it's not very easy to be detected through any normal algorithm, or let's say even advanced algorithm. However, with our algorithm, it is detected. You can see the fire message on the screen right now, and you can see it. This is exactly the benefit that we are talking about. You can see here how fast the camera or the algorithm on the camera was able to do this detection. If this is there and the operator understands that this is happening, and then everybody starts to go directly to put this fire down, that's where you don't really need to go to the smoke part where people start to have problems, or let's say to avoid any problems. And then still the alarm itself is a very early stage, so the situation is controlled very quickly. So that's the main benefit. Another benefit is very important because of the tunnel. Inside the tunnels, there is normally the fans, and these fans are pushing the smoke away. So if you are relying on the normal or conventional linear heat detectors, actually the fire detection is reaching this linear heat, the fire is reaching this linear heat detection very late after damaging a lot of things before going there. So the normal fire detection equipment currently on the market and currently used everywhere in the tunnels, they are detecting that part very late, which will give us back to the point that we are going very late to manage the fire over there. If you are starting with the smoke to detect the smoke, still the fire getting very big and very dangerous and causing a lot of problems and a lot of death. So comparing our technology right now with the conventional technologies that are in the market, with the normal algorithm, with the visual cameras, we see a very big advantage and a very big advances that we can use. Of course, the accuracy of the fire location, that's also something that we are talking about here, because with the camera, you know exactly where is the fire and what is the shortest way for the firefighters to go and actually control the fire. While with the linear heat detector, you know that there is a fire, but you don't know exactly what it is. You have to go back to the cameras to detect, or let's say to understand. How is our algorithm is working? That's an image, or let's say a visual of actually a fire or a test fire that is currently taking place. Our algorithm is pretty simple. Of course, it's how to do it. That's the benefit, or let's say that's the added value. But from a logical point of view, it passes through different stages. So the first stage is that you are actually doing a temperature monitoring. If the temperature of that object, of that part, of that image is going above the threshold, then we understand that there is a something is happening here. We need to take a closer look. And then closer look here is the second stage. What is the behavior of that event? Is it moving? Is it changing? Is it a spot? It's a hot spot that is not moving? Is it static? So actually, that's the question. If it's static, then we conclude that this is a hot spot. Hot spot is something that is hot in the field of view of the camera, but it's not a fire because it's not moving. However, if the shape is changing and the volume is getting bigger, as you can see on the right side of the image of the video or the slide, you need to take an immediate action and we raise an alarm. This alarm can go to several ways. Either can pop up on a screen for the operator. We can integrate with third-party SCADA systems. We can deal with the third-party ITS platform. So basically, our Flux software, which is the back end of our system, can integrate with any third party using normal SDK, or let's say SDK free of charge that they can actually do customization, or we can use OPC interface that can operate with anything. So basically, what we are talking about here is the flexibility of our system to understand what's going on and filter the alarm based on the behavior and on the shape and the volume of the fire, that, or let's say, of the temperature that is coming high. Why we are talking about that as a specific and why we are concentrating on that? Because the hotspots, it's something that is very common inside the tunnel. We can see hotspots because imagine a car or a truck going around the tunnel. The rooftop of the car is hot. So when the car comes inside the tunnel and other algorithms are based or are using the hotspot to detect that this is a fire, that will be a false alarm. And that's one of the main things of this benefit, or let's say the benefit of a system like that. And the reliability of that system is to have low false alarm. We cannot rely on a system that is causing a lot of false alarms. Here also, it's the pipes or the exhaust pipes. That's something from, let's say, a truck that is coming that you can see that is going as well. It will create a false alarm to that hotspot detection. Finally, a hot engine. An engine that is actually moving with the car will show us that this is a hotspot and it will make problem to that algorithm. Do you have any questions? Please, I agreed also with Sid that if you have any questions, please just write it. And if you have any comments, if you can hear me quite, please let me know. If you want me to put the headsets and speak a little bit more with the headsets, just let me know.
Mr. Enan, actually, we cannot hear you very well. Your voice is loosely. You also have the questions on the right side of your screen. It's related to about car engines, how these actually car engines can affect the performance of thermal imaging cameras. Thank you.
Can you hear me now better?
Yes.
Okay. So again, excuse me, what is the question again, just to make it?
Actually, you have it on your right side of the screen in the chat option.
Can you read? Because when I'm doing
yes. How car engines can affect the performance of thermal imaging cameras and analytics.
Okay, so thank you for that question, because exactly that's the thing, that it is not affected. That's basically it's not affected because we are not relying on the thermal, we are not relying on hotspots detection. We are actually relying on the visual of that camera, or let's say on the behavior of the fire, and we are also detecting the temperature increase. So basically, with our analytics, and that's exactly that slides, we don't have any problems with engines going inside the tunnel and causing any problems. Did I answer the question?
Yes, confirmed.
Okay, any other questions?
You can proceed with the presentation.
Thank you. Please, if you have any questions, just shoot it around, because I know with everybody has experienced in the last 2 years of the corona, it's not very easy to stay 1 hour listening on a Zoom link. So it's better to make it a little bit more, let's say, with questions and answer and more interactive. So going back to what we have been discussing, we don't want to compromise on anything. We want the thermal part, because this is actually where we are doing the fire management. This is where we are seeing what's going through the smoke. We are seeing the visual. We need the visual as well, because the operator still wants to see the visual part. We want to do data collection, and actually the data collection can be done on both images, the visual and the thermal. I just put it here on the visual because it is shown on that screen that we are doing counting and the average speed of the cars, a lot of information about the traffic. And finally, we want to have let's say, the most reliable system. We don't want to see false alarms. We want to have a system that when the operator sees there is an event, he actually go and do something, or he will actually take the right action. So we don't want him to see every day 5, 4, 10 false alarms. So he will get used that this is not a false alarm, and he will not actually react if there is something happening. How we are doing this? We are doing this through the deep learning, artificial intelligence, deep learning. Before going to the deep learning explanation, we want to talk about what is artificial intelligence. Artificial intelligence is the ability of machines to mimic certain tasks like decision making and problem solving. And this is, we are actually replacing the human by machine. This is something that has been in the market for more than 50, 60 years, but let's say right now everybody's talking about. We have been doing that since the 1990s, as I've shown you in the beginning. Other companies have already started that from a very long time. So the artificial intelligence is the technique to enable computers to mimic the human behavior. From that, we can see also the machine learning, which is a subset of the AI, which uses statistical method to enable machines to improve with experience. And finally, we are getting into a deep dive to the deep learning, which is a subset of machine learning and can do actually in a multi-layer neural networks to make use of what is the technology is happening right now. We are seeing the fourth industrial revolution. That's the term that we are actually seeing. That's the revolution we are currently living. That's something very exciting for everybody to be able to witness that happening. So basically how we are using the deep learning, you can see on the left an image of a dog. Okay, so that image it's coming, the neural network is actually discussing if this is a real dog or not. Or you see on the right side, on the corner, there is a muffin and there is a mop. Which one of those is a muffin and a mop? So basically the neural network, what it's doing, it's, as we said, it's mimicking the human recognition. And it's actually since 2015, 2016, it started to surpass the human recognition. So some of you will miss the decision if it's a muffin or a mop, while with the neural network, it will not miss. It will give a very reliable answer. And this is what we are using currently in our algorithm. What is happening also in the market, we have seen a rapid innovation. We have seen a lot of companies going around saying, okay, we are doing AI, we are doing artificial intelligence, we are doing deep learning. And that's a very important question to ask. Is it really taking place or not? Are they really doing it or not? And the thing here that a lot of open sources are on the market. Some people are using this open source to actually ask, let's say, to do their artificial intelligence. And our answer to that is, are you familiar with this? You have seen this on Google, you have seen this on many other applications, and you understand that this is something that you are actually teaching the algorithm. What is the sign? What is the car? What is the airplane or something like that? So we are giving that information. So basically the artificial intelligence, that the added value of any algorithm, it will be the input, or let's say the data that is teaching this algorithm what are those events. And this is where we are one of the pioneers, and we are one of the, let's say, biggest company which have around 1 billion vehicle detected per day in all our systems. We have videos and data that was our source code. So basically, this is where we are having the intelligence and important information to teach our algorithm how this is look like, or how our car is looking like from all the aspects. Not only about the visual performance, but with the thermal performance. And that's the main advantage as well. So basically having a visual and thermal data sets, teaching the algorithm how this is working in both lives will give us the added value of having a real artificial intelligence and deep learning algorithm working and reliable. Any questions? I see here a question, what will be the intervals of installing the cameras inside the tunnels? That's a very good question. Basically, we are, normally it depends on the height of the installation. So the height of the installation, so the ceiling of the tunnel, we are talking about normally the ceiling of the tunnel between 4.5 to 6 meters. We are recommending that it actually goes 20 times the height. So if we are talking about a height of 5 meters as an example, we normally put between 100 meters the cameras. If you want to do pedestrian detection and object detection, we recommend to reduce it a little bit to 70 to 60. So in a nutshell, my answer would be from 60 meters to 100 meters, depending, of course, on the bend and the geographical location of the tunnel. But this is a very good question because we also get this question a lot. So a deep learning visual versus the thermal, and that's exactly what I have been discussing before. With a visual stream, still it's a very good stream in order to see it for security purposes. However, in a day like that, or in a very bad lighting, you don't see anything. So basically, if you have the best AI or the best deep learning algorithm, you will not be able to see what's going on. However, on the thermal part, on the right side, you can still see the cars, you can still see through the rain, you can see through the smoke, you can see through the dust. So whatever is the weather condition or the lighting condition, you are capable to see through that. And hence your AI or deep learning algorithm will be working. So the FLIR ITS AI deep learning concepts are done through two, let's say, approaches. So the first approach is through a deep learning engine, which is uploaded or let's say installed on the back end on our Flux servers. So basically, if you have an event or you have a smart camera with our analytics or with the third-party analytics, let's say third-party cameras with our boards, and we have the analytics, we will send this information to the Flux, and we on the Flux we will do that check of this is a false alarm or that's a true alarm. And through that engine, we will filter all the false alarms and send only the true alarms to the Flux server that will take the action, the appropriate action. So basically, there is no extra hardware, it's on the same server, no network delay, minimum network load, because we are not pushing more information. All the information is coming with the same camera. It's scalable as well, and with a higher performance and very low alarm rate. And you can have new applications on that. Basically, you can, for example, if you want to see specific car or specific type of car, you can do the classification of that car, and you can filter all the alarms that are not related to that car. So it's also very flexible. What is the end user want to do? The other approach is to actually have the AI on the edge, and that's the new thing we are promoting in the next year or this year, at the end of this year. So our cameras will have the embedded algorithm on the camera, so the detection and the library will be on the camera itself. And the communication will be going through the traffic management. So there is no network latency in that case, so all the events are taking place at the same time. The deep learning algorithm detection is on the full frame rate and the full resolution we are doing on the camera resolution itself. And of course, input output directly from the camera. If you have an event and you want to take the inputs, or let's say the output of the camera, and to put it in an input for something that is locally based, you can still do that. And you can actually remove any false alarm in that case. I see another question. Hello, what will be the intervals of installing the camera inside the tunnel? We already asked that question. We answered that question. Let's say we have such camera in tunnels and after some time the lens get dirty. What is the percentage of fire recognition and how fast will the camera respond? Okay, for the dirtiness, this is applicable for the visual cameras. For the thermal cameras, we don't have this problem. And this is also a very good question because it answers the question. If there is dust on the camera will still see through. So in order to have a dirty lens for the thermal, you need to go and actually put something in front of the camera, and which is actually not happening. So my answer will be, first of all, the detection and the algorithm will still work 100%. If you have an exceptional alarm or something that is really blocking the visual of the camera, or let's say the thermal part of the camera, in that case, you will get an alarm saying that the camera is not performing well and you need to go do the maintenance. So you will have a preventive maintenance in that case, and you will not wait till the alarm that is, you are missing an alarm to understand that the camera is not working. You will actually have an alarm saying that the camera needs to be cleaned and we cannot see. Another question, can we distinguish a truck from a bus in the slide? That's with our AI coming in the market. Exactly, you will be able to do the distinguishing. The classes, we are having more classes with the AI algorithm taking place. Currently with the thermal, you have 5 classes. It needs to be a little bit a longer truck and the difference between the bus for our current algorithm. But for the AI algorithm, definitely you will be able to do this differentiation. So that also in order to answer your question. Going into, coming back actually to the deep learning, the added values. What are the added values? We are talking about avoiding the unwanted alarms. So basically, one of the alarms that we don't want to see is the inverse shadows. Because of the shadows and the difference in the lighting, with a visual camera, you might have problems. I will not say that for all the, let's say, not all the time, but during some time with the changes of the light, the sun moving, you might have inverse shadows and you will not be able to see, let's say we will have more alarms. With the deep learning algorithm, you will remove all these alarms because you will understand that there is no problem in that case. Same thing with the snow tracks. If you have snow tracks, then you might see an alarm as well. This is all filtered with the new deep learning algorithm. Same thing with the tree shadows. As you can see here, in the morning, you don't have this problem because the sun is on the other side. The shadows is actually outside of the road. With the sunset coming, the shadows started to move and make problems and make false alarm on the roads. And that's basically one of the benefits of the deep learning. Piles of snow, same thing with the thermal cameras. Even you can still have this problem because of the snow and a lot of changing in the conditions that will affect the algorithm to make false decisions. With the deep learning, you are removing all of that. Of course, with the traffic data, we are getting more traffic data, more classification, and this is also answering that question. We have more classes and custom classes. So between truck, between bus, truck, even longer truck, shorter truck, even let's say we have motorcycles, bicycles, trucks, all of that, we will be able to do different classes and custom classes. The speed measurement will be a little bit more accurate. Accurate accounting, of course, we will be able to get accuracy of the accounting up to 98 and 99%, which we already have with the thermal. So with a visual, we will be able to reach the same values. We'll be able to improve handling of camera vibrations because the camera vibrations a little bit sometimes affecting the data, our data. The camera will be in a better position, so we don't have to be, the occlusion will not occur so much. Why is that? Because of that imaging. We are going to do something like We call it digitizing the traffic. You see on the right side, you can see the cameras, or let's say the cars going from first camera to the second camera to the third camera with the average speed, with the trajectories. So basically with the AI coming in, you will be able to see the trajectories of the cars. So even if a car is blocked in one of the cameras, you will see it in the other camera, or even you will understand how it's moving, and you will be able to decide where the cars, how many cars are there, how they are trajectories. If there is a situation, you will be able to understand it quite well to improve the traffic in the near future. So that's something that is very important to see it, and the operators in the tunnel will appreciate that in a very decent way. We can see the heat maps. We can see where are the cars moving, when they are taking into the left on the intersection. That's a little bit outside on the intersection side, not in the tunnels, but outside the tunnels. You might still need, for example, you are going outside the tunnel and you are reaching an intersection. You want to see if the queuing coming up on that tunnel, you need to reduce the speed a little bit and to learn the people that to reduce before going outside. So these classification and trajectory controls and heat maps, we call it digitizing the traffic. You will be able to understand the situation that is happening and how to deal with it. It's the same thing during the maintenance work. During the maintenance work, sometimes the cars come and stop and they put boxes and they put cones and put stuff like that. During that time, you can understand, you can imagine how many alarms you are getting. It's getting all over the place. You are having the alarm. You need to stop your system in order to not be bombarded with 100 alarm at that time. Our algorithm, or let's say our AI, will be able to identify those cones and boxes and the behavior of the people, and will be able to remove all of that from the alarms, let's say, from your system or from your database. Finally, we don't need to compromise. We want to get everything. You don't really need to choose between the visual and thermal. You can have the thermal and the visual. You will be able to use that in a harsh environment. The casing is stainless steel. You don't really need to change the case anyway. It's finished. It's you just put the camera directly. There is no corrosion that will happening on the camera. The detection is on the edge. There is no latency, and will make sure also that your deep learning algorithm will reduce all the alarms. You will have more classification, more objects, and you will have also modular classes to do. Continuous improvement, and as soon as you are getting more data and more information, the camera will learn and the algorithm will be even better. Finally, with our flux and our situational awareness, you have a full vision of what's going on your system, and you can integrate with any third-party SCADA or ITS platform, again, as I was mentioning. Thank you for your time, and hopefully our tunnels are becoming more safer by using the right technologies and combining every possible way and every possible technologies to save lives and to have our guys going on the road, our relatives, our brothers and our sisters safe while they are traveling in our tunnels. Thank you, and please, if you have any questions, I still have some time to answer your questions.
Enan, hopefully you can hear and see me.
Yeah.
Thank you very much for your presentation. Actually, before the final words, we have one more question. It's about tracking the target objects. Is that possible with AI?
Yes, with AI, as I was just mentioning in the last few slides, we can do trajectories. So with the trajectories, moving from one camera to another, we will be able to track that camera, or let's say that car. So if this is the questions, yes, you will be able to do something like that, and to be able to track the vehicles and the trucks that are moving inside the tunnels from one place to another.
Okay. And thank you very much for delivering this presentation and for great time here. Definitely great solution. And actually, we are expecting more from FLIR, definitely. So in that regard, can you tell us this is actually a question for me. Can you tell us what we can expect from FLIR in soon future, let's say?
We are currently, as I was mentioning a little bit during the presentation, we have evolved from, let's say, board detection to camera IP detectors to thermal detection. And right now with the AI deep learning algorithm, we are moving towards that part. So basically in the near future, we will see, let's say, the advances on two parts. First part on the visual, we are trying to use more megapixel cameras to have our algorithm on that megapixel cameras. Right now, we are doing it on high definition. We are looking forward to do it on 4K and even, let's say, the latest technologies. On the thermal part, we are trying to put the AI algorithm on that camera in order to have our, let's say, standard uh, thermal solution with the AI algorithm on it. So basically combining all of that into one dual visual camera, or let's say visual and thermal, is the latest updates we have. And definitely we are moving towards a more sustainable, let's say, and more reliable solution. That's main our target. And basically, again, with all, let's say, the combination with Teledyne and Teledyne FLIR right now, we are having a full set of solution, including the video management system, the storage. So we are not only providing AID cameras, but we are providing AID cameras with also PTZ cameras, all of that integrated to the Latitude video management system, completed with the storage. So a full solution for the interurban application. Of course, today I didn't want to speak too much about also other urban application for the intersection control, because I don't want people to get a little bit of, bombarded with all the information. But definitely we can have another session sometime later to be focused on the urban applications only.
And thank you very much. If you don't mind, we have one more question from Mr. Zoran. It is about the solution for, do you have actually a solution for wildfire and smoke detection?
So for what, sorry?
So for wildfire and smoke detection, probably this is apart from the tunnels.
Apart from the tunnels, like normally in order to do the smoke detection, it needs to be a closed area. That's one of the most important part. And that's what we are doing it through the visual cameras inside the tunnels. Outside the tunnels, we can still do the fire detection. We have other equipment as well, maybe in Teledyne FLIR as well, to do the, say, to do detection fire inside other applications for petroleum application or something like that. We are more focusing on the fire detection for traffic applications. So we are actually installed that, for example, this camera that I was talking about today in Turkey for Çanakkale Bridge, to do also fire detection on the bridge. So that's something that we can do on bridges or highways.
Okay. Dear participants, thank you very much for attending today's webinar, today's presentation. This was Hesham Enan from Teledyne FLIR. He was talking about the detection of incidents in tunnels and highways. So thank you very much for attending. If you have any questions, feel free to ask us, and we will proceed these questions to Mr. Enan and to our partners. So thank you very much and see you next week. Goodbye.